то, что вы с нами. Я хочу вам представить нашего следующего докладчика. Это Guillaume BOUCKAERT из Fishing Cactus. Он уже работает 4 года геймдизайнером в этой компании и любит готовить суши и расскажет нам про веселое программирование Algo-Bots. So,
Okay, okay, perfect. All right, so like she said, my name is Guillaume BOUCKAERT, and I'm here to talk about Algo-Bot, or how coding can be fun. How coding can be fun. So just to introduce, I'm working on a company called Fishing Cactus, which is a small video game studio. It's based in Belgium. It's a small country between France and Netherlands. And well, the company has been running for like the past 5 years, and we're about 30 people now, so it's grown quite well. And we have an unhealthy habit of making what we call serious games, which means something I'm going to explain right up next. So Algo-Bot is a serious game story, but here I'm explaining what I'm going to talk about in this talk. So I'm going to explain what Algo-Bot is, of course, and I'm also going to explain how we actually found the gameplay into the game, how to find fun in a settings that doesn't really stand for it. And then I'm going to explain how we demonstrated the different parts of gameplay and through the different situations. Okay. So Algo-Bot, as said, is actually what we call serious games, and what serious games are is games that are here to teach you about something. But they remain games first and foremost. They're not a teaching tool, classic teaching tool. They have to be games first, because in our mind, all gamers are students. Whether you're learning, the economics of StarCraft 2 or learning to do the tricky jumping in Super Meat Boy, every time you're learning something. So in our minds, we just tapping on that learning potential to actually make a game around it, and making sure that what you're gonna learn into the game can be useful for I don't know, your future or your life or your studies. And it's what we're doing with Algo-Bot. Yeah, so Algo-Bot is a series of games about coding. Yeah, and in this game, players actually learn the logic that goes on behind coding rather than actually do any line of code. Meaning that they're gonna learn what's the different concepts that go on behind it, the patterns that you have to learn and wrap your head around to actually execute any code if in the future. In our mind also, when we started the project, any players could come and actually play Algo-Bot. You had to have no prerequisite to enjoy the game. It's just a simple normal game. It's a serious game, of course, but it's a normal game that anybody can play and pick up, and through the course of the game actually learn about coding and the logic that goes on behind it. So when we first worked on the game, we sat down and decided on different, I would say, concepts that we wanted to put into it, and there were quite a lot. The first one was the set theory, so it's how to say in English, the different way that you have sets of variables and the way they can interact with them. Then we had the functions, of course, variables. We wanted to also to use the if conditions, for loops, while loops, and then the object creation afterwards. So all those quite complex concepts actually had to be transformed into gameplay elements in our games, into gameplay features, and be understandable through the gameplay for the player, and so that they could actually learn from the game. So the solution to finding a gameplay that could encompass everything, and that all those pretty heavy and high-minded concepts, our solution to that was to make a game about robots. So in these games, in Algo-Bot, you have one little robot, and that has to reach a goal, carry objects, or anything like that. And the way you play is that you give him a sequence of instruction, and they will follow that sequence once it's built, and move around the environment. And then if you're not happy with the sequence, can just stop the game, start over, rewrite the sequence again, and keep going until you've achieved the goal that was set up for the level that you'll be playing. So that's what the game looks like. So you can see in this screenshot that there is the robot. Then there is the goal that you have to reach on the far end, the green light. And then there is on the bottom, in the HUD, you can see the different sequence that you can use. You have the main sequence when you put the instructions for the robot. So it's a move. In this case, it's a simple move forward, and then use to actually trigger the exit. So we wanted this sequence creation to be a pretty much straightforward. It's just a drag and drop feature or click. You can very easily create a sequence for your robot to follow. So it's like I said, the Algo-Bot is a serious game about learning the logic behind code, but we don't ask you to actually write any line of code. You're just inputting instructions, selecting them, and giving them to your robots to follow. So the list we had was like very basic, like move forward, turn left, turn right, use, and then some others that are a bit more complex, and I'm going to talk about. But even though they might be complex, they're still very easy to understand and to use. And also we made sure that for the player, it would be very easy for him to actually learn from his mistake. And then we heavily count on the trial and error in the games to make sure that some heavy, more complex concepts can be quickly understood. But for the to make sure that the game could be understood, that the logic of the code is understood by the players, what we based our game on was the patterns. So you've seen it in the screenshot of the game before, that the environment is divided between nodes that the robot can travel from one node to the next, etc. And what we do is we actually make patterns in the level, so they easily stand out, and you can easily understand. Okay, to reach certain goals into level, you will have to follow those patterns around. And that was one of the level editing rules that we put into the game when we started productions. It's that every level has to have some kind of patterns for the player to discover and then understand, and so create the sequence afterwards. So it became a prerequisite for the player to actually read the environment, read the sequence, find the sequence actually from the pattern, and then create it. And what we also wanted the game to be about is, like in code, you had to be as efficient as possible. So in the screenshot I show you, you had a sequence of instructions that you had to input for the robot, and the less instructions you were using, the higher score you would get. So just like in coding, you had to be very efficient with the limits that you had into the game. So yeah, the use of pattern, the efficiency, that was the feature, the foundation that we had, that we wanted for a game, and every other concept that we put into it. So the bit, the if condition, the for loops, everything is derived from that, and is using that pattern definition that we put into the game. So in a way, we found the fun of coding that way, and then we built into it. So here I'm going to talk about the different type of gameplay features that we use to make the different concepts that went into the game. So like I said, the set theory, the user function, the if conditions, for loops, etc. So the first one, the set theory, the way we use it was like a secondary goal for the player in the different levels that he was in. So before reaching the exit, you had to go move the robot around and gather different objects. And those objects had a different color that was linked to one or two sets, and there were intersections on those sets. So in a way, we put that the set theory, quite abstract feature, and we put that into the game into an object that the robot had to gather around. Next, the functions. Well, the functions, when you think about it, it's really the backbone of programming. And the way we put that into game is that you have the robot has a main sequence, of course, but there are also a separate sequence that you can use, separate sequence of instructions that can be called anytime from the main sequence, or can be called in between each other. And it's introduced very early into the game to make sure that, well, it's a very, you could say, high concept, but actually it's it's basic of programming. So we put that very early into the game, and every other concept is derived from it. We justified the use of function and to the use of repeatable patterns into the level. So like I said, every level is built with the repeatable patterns into mind, and it highlighted in a way the different functions that we had into the game. And like I said before, it could easily be called and as many times as possible using the different set of instructions that you had at your disposal. And you could link them, do links between them for heavier tasks and difficult tasks where the patterns that were repeated were actually more complex and intertwined into each other. Next, what we put it in the game were the variables. And here we put the emphasis on their different type and actually the value. So variables are quite an abstract concept when you think about it, and putting that into the game was quite difficult. The way we did it is by having different kind of objects again that the robot has to use and treat and gather around. And we focused on three main type of variables, so the boolean, the integer, and the string, and put one kind of objects for each and every one of them. So like I said, the material, they are built into the game as objects that the robot has to find and carry around. And every one of those type of variables is actually behaving in a way that's linked to the variable it represents. Meaning that whenever you carry one and you have the value that's available and visible, and you have to count onto that value to actually make some tests afterwards. And that value is updated, of course, and the way that the variable it's linked to will update. So for example, if the robot is carrying at one point a variable that's mimicking the boolean, it will either stay, for example, it's a container of toxic waste, it will stay either empty or full, meaning that its behavior is mimicking the actual behavior of the boolean. Okay, so the way we did that is that, of course, we can let the player actually use any variables that he wanted and just stackpile the variables. We used a color code to link the actions that the robot was doing to the variables of the game. So he had different color slots that were available for use, and you were linking your action to the colors, meaning that if you put color on specific actions, then that action will be linked to that variable. So in a way, we use that a color declaration, if I may, for the variable before they were actually being usable. And that color became also the function parameters in a way, meaning that you could also color not only your action but also the functions. Putting a specific color on a function will mean that the parameter you will send to that function, again, it's pretty heavy stuff for programmers, but it will mean that that actual function will use that variable inside it for every actions that the robot was doing. So in a way, we were able to put the function parameters in the game as well. Just a small example of how it worked. So here you can see the main sequence of the robot, and I've input different instruction linking the actual functions of the robot. And by coloring those instruction slots linked to the function, I'm actually linking that function to the variable I want to use, in this case the yellow variable. Then the color is forwarded to the all actions in the functions, and the robot, when he's doing actions in that function, is going to use the yellow variables. So it's really like parameters for a function, and the repeatable patterns that were in the game, some were linked actually to the use of the gathering of those objects, the variable objects, and some were not. So meaning that in some of the levels, we had patterns that sometimes required you to use color with the function, sometimes not. So just an example of what I was just talking about. Here you can see that we have patterns that the player has to use, and some of those patterns require you to use a color with that function, and some do not. Next up, we required the player to actually use the condition. And the way we built the conditions into the game was by developing on that color system that we had developed at first. So you had you could use do basic tests between the actual variables that are in the game that were actually colors, and whenever the test was okay, then it would trigger its own sequence, and you could use that sequence to actually make it into loop at referencing it itself. So again, one of the basic of the game was to make sure that the player had fun making the sequence for the robot as efficient as possible. And that's one of the way the player could actually do it, is by referencing the condition to itself. So in effect, you would create a loop into the game. And then the last concept that we inputted into the game was the for loop. So in programming, the for loop is used most of the time to parse a list of objects or variables or what have you. The way we do that is that, of course, we couldn't make sure that the player was incrementing or doing tests on the values that he had gathered into the game, because those were, in a way, objects, so there was no way that would have worked. So for us, the only way to actually implement that logic of the concept of the for loop was to make not linking to the actual variables, but to the movement of the robot. So the movement of the robot become the repeatable actions, the repeatable unit that the player has to use. The way we did that is that some functions can actually be tagged and repeated a certain amount of time. And by tagging actions into the sequence of the function, then those actions get repeated in time and in pattern with the actual function that you're calling and repeating. So again, it's linked, in a way it's linked to the level editing that we do into the game, meaning that the certain patterns that you see into it become the basis for that the player has to read and then build his function around. Okay. And next up, the last feature that we actually put into the game was the secondary robot. So the secondary robot was, in a way, the creation of objects that you see in programming. And we had, you could have as many as 3 different robots, and every one of them could share functions between one another. They could also transfer variables, so send variables from one robot to another, again with the gameplay of the car that we inputted in the game at first. To wrap this up, there were a few features that we couldn't put into the game, and the main one was actually the recursivity. We tried to make it to put it into the game, so the way it works is like a function, you put the reference of a function inside the same function. And for us as game designers, it made the level actually quite easily breakable by the player. And it broke our score system as well. So in being safe-minded, we decided to actually remove it from the game. We used the self-reference to create the while loop into the game. So in if condition, you actually reference itself to create a while. But other than that, we didn't want that into the game. Plus, it would have rendered the while loop useless, so it wasn't a good idea to keep it. So that was pretty short, but so this was Algo-Bot. It's our series games about the logic behind coding. It's going to be soon kicked out on Kickstarters, and I know this was pretty short, but if you have any questions, I'm available for them.
Do you have some questions?
Probably not.
And could you please tell us what sounds in game do you use? You use your own sounds, or you use a library of sounds?
Maybe I can jump at that, and more like the engine that we use instead of the sound. We use our own engine for the game. It's called the Mojito engine, and own 3D engine that we built over the last 4 years, and we've upgraded it with every passing project that we made.
Okay, thank you so much. You can find. Okay.
Oh, cool.
Do you plan to release that game just as a regular game, or maybe you have some interest from schools or other educational establishments?
Right. Sorry, I didn't specify that. Actually, the game has already been released in a school in Belgium, but we're looking into partnership with a different school. The school it's been released to, it's been part of the courses for the better part of the last 6 months, I think. So the students have to play the game to actually pass the courses, which is fun. I mean, when you think about it, and it's part of the Kickstarter as well. If it's successful, we plan on releasing it and giving it to some school for free.
Okay, thank you so much. We don't have enough time for questions. Thank you, Guillaume. You can find Guillaume at the conference if you have some questions to him.
We're actually presenting the game downstairs and the game.
So you can find an indie price.
Yeah. Okay.
Thank you.
Welcome.